Hello everyone, welcome to Exemplar Physics. For the students of class 10th who are going to write board examinations this year, I have made a playlist for them. The link is in the iBird. In the playlist, I have made 5 videos discussing the question paper pattern as released in the sample paper released by the CBSE. Then I discussed physics questions asked in the papers section wise, telling you all the concepts involved behind the questions, and I hope that those videos are really helpful for you. After that, I am trying to make short videos regarding the concepts and the questions that are not asked in the sample paper and may be important for the board examination. So I'll making those short videos and releasing every bit in a while. In this video, I'm going to discuss the section A of second pre-board examination, which was conducted last month in March of Bengaluru region. I think the set of questions which I are going to discuss in this video are really important, and if you really count them, there will be 18 questions. 18 very good questions we'll be having here. We'll be discussing it. So please watch the video until the end. And one more information for the viewers, we have Exemplar Physics Facebook page, we have Exemplar Physics Telegram channel. The links for the both will be given in the description section. You can join me there and you can ask doubts there. I'll be clearing your doubts there. And one more thing, so we have reached 49 subscribers for our channel, one less than the half century. So please spread the word about the channel to your friends and family members and encourage me for making more and more videos which would be useful for you. Now let's begin our video. So as already mentioned, I'll be discussing section A, and each question in section A carries 1 mark. So you do not have to write too much explanation. So let's begin the video. Question number 1, which is question number 5 of the question paper. Let's see the question. Where is the magnetic field uniform in the diagram at A, B or C? Why do you think so? So this is a diagram, there's a diagram in the question. So here is the diagram. So you can see it's a solenoid, and there have been 3 regions marked, A, B and C. So where is the magnetic field uniform? How do we represent a uniform magnetic field? We will represent a uniform magnetic field by drawing field lines parallel to and equidistant to each other. So parallel and equidistant lines indicate uniform magnetic field. So this is a uniform, represents uniform magnetic field. I suppose that you already know the properties of magnetic field lines. I just want to highlight 2 important properties here. The first one being the magnetic field lines are closed curves. Second important thing is no 2 magnetic field lines intersect each other. So they do not intersect each other. Why don't they intersect each other? They do not intersect each other because at the point of intersection there would be 2 directions of the magnetic field, which is not possible. So keeping these 2 things in mind, I am going to answer this question. So if they are closed curves and they are not intersecting each other, then how are they going to exist inside the core of a magnet? So the only way they can exist is being parallel to each other. So parallel magnetic field lines indicate what? Uniform magnetic field. So let us answer this question. So what you will write in the answer? The answer is like this for this question. So the first part, where is the magnetic field uniform in the diagram? So magnetic field is uniform in the region A. So you can write at A. And why do you think so? So you can mention these 2 points here, that magnetic field lines are closed curves and they do not intersect each other. Hence, in order to coexist in the core being a small region, they must be parallel to each other. Therefore, the field is uniform. So this answer perfectly explains why the magnetic field is uniform inside a solenoid. You will be getting half marks for this, for writing where it is, and for writing the reason another half marks. Remember the question section A, all questions are of 1 mark. Let's go to the second question. The next question is question number 7 in the question paper. Let me read the question. A light ray enters from water with a refractive index of 1.33 into ruby with refractive index 1.71. Which angle is greater, I or R? So I indicates angle of incidence and R indicates angle of refraction, and it is also asking the reason why. So let me write the data given in the question. Given refractive index of water, let me write it as mu w, and that is equal to 1.33. Refractive index of ruby, it is given as 1.71. Now the light is traveling from water into ruby, right? So by seeing the refractive indices, you can tell water is, comparing these two, is optically rarer medium, and this is optically denser medium. By just saying the refractive indices, you can tell that more refractive index, more denser is the medium. So what is the concept involved here? As the light travels from optically rarer medium to, so rarer medium here we have water, to optically denser medium, that is ruby, it slows down. And what is the consequence of this? The consequence is that it means the light bends towards the normal. So let me take an interface here. So this is the interface between the water and the ruby, and suppose this is the incident ray. This is incident ray. So this is water, this is ruby. So light is traveling from optically rarer medium to denser medium. It slows down and hence it bends towards the normal. So this is the refracted ray, the red one. So what is the angle of incidence? The angle between the incident ray and the normal. And what is the angle of refraction? The angle between the normal and the refracted ray. So you can say that angle I is greater than angle R. So the question consists of two parts. It's asking which is more, I or R, and it is also asking why. So you have to write this reason. If you have understood this, I have a question for you. So in refraction, always there would be difference in angle I and R. So here is the question. Is there any condition when the light travels from one medium to another and angle of incidence is equal to angle of refraction? Is it possible? If it is, please write your answer in the comment section. Let's go to the next question. Question number 8. The question is, draw field lines around a bar magnet. So we need to draw field lines around a bar magnet. So let me take a bar magnet here. So this is the bar magnet we have. It will have two poles, north and south pole. So please don't draw too many magnetic field lines and make it clumsy. In the exam you have to keep it very neat. That would give a good impression on the examiner. So how do we do that? So draw a few lines here, one line straight. Okay, the magnetic field lines originate at north pole and terminate at south pole. So don't draw too many lines, just a few to understand the pattern is enough. So I'll draw one here like this, one more like this. Okay, one like this, one more like this. So this is enough. Start from north, end at south.
Start from north, end at south. Start from north, end at south.
Okay, you can draw one more like this. And please see that no rays get intersected by each other. Okay, the magnetic field lines are closer near the poles. It indicates it's a strong magnetic field. Be that north pole or south pole, magnetic field lines are closer to each other. So if you draw like this, it looks neat and it gives a better impression on the examiner. So I hope you understood. So let's go to the next question. Question number 10 of the question paper. The question is, why are danger signals red in color? So why are danger signals red in color? So one mark question. So what shall we write? So let's describe about red. So let me write red with red. So red color being the longest wavelength. Okay, it's the longest wavelength. I am kind of considering only in the visible range of light. Let me write that also. In the visible range of light. So being a longest wavelength, scatters least. So in the atmosphere you have gases, you have dust, you have smoke, right? So it scatters least, hence can be seen from long distances. The person should understand from a long distance that danger is ahead. That means the information should reach him. So how is that possible? In the given visible range of light, red being having longest wavelength, scatters least. Hence the light reaches to longer distances and you can see it from long distances and you can be alert. So that is the answer for this question. That's a good question, by the way. So let's see the next question. Question number 11. Question number 11. A lens is of focal length plus 10 centimeter. Calculate its power. So let me write the given data here. So focal length given here is plus 10 centimeter, and that it is a lens. So what does plus indicate? Plus indicates that is a convex lens. And what is the formula of power? Power is equal to 1 by focal length. Remember, this focal length should be in meters. That means we need to convert this focal length in meters. So what is F? F is equal to 10 by 100 meters. So here the answer will be 1 by 10 above 100. So don't forget the plus. So the answer will be plus 10D. D is the short form or symbol for diopter, which is power, which is unit of power. So that is the solution. And there is a OR question here. Here is a question. Find the focal length of a concave mirror whose radius of curvature is 32 centimeters. Radius of curvature 32 centimeters. What type of mirror is that? Concave mirror, according to the question. So what is the relationship between radius of curvature and focal length? So the relation is F focal length is equal to R by 2, half of the radius of curvature, given the aperture of the mirror is small. So what would be the answer? 32 divided by 2, 16 centimeters. And if you apply new Cartesian sign convention, then the focal length will be equal to minus 16 centimeters. So this is the answer. So let's see the next question.
If you have any doubt, please write it in the comment section.
So next question is question number 13. So let me read the question. Why is a nichrome preferred as heating element? Give 2 reasons. That means each reason will consist of half marks. What is nichrome? It's an alloy, right? So the question may also be asked as why alloys are more preferred in heating devices than pure metals. So what could be the answer? So there are some advantages. I'll write it on the board. You can note it down. You can pause the video anytime if you are noting down. So first thing, nichrome being an alloy has higher resistivity. So more resistance, more heat than that of its constituent metals. This is the first reason. The second reason is alloys, or you can say here the question is related to nichrome, so you can say it does not oxidize or react readily at high temperatures. So these are the 2 reasons, 2 valid reasons why alloys like nichrome is being used in heating device. And there is an OR question with this. Now let's see the OR question. Define Ohm's law, write a mathematical expression for it. So let's write Ohm's law. This is the OR question. Remember, in the exam, whichever question you know the best, please answer that. So let me write Ohm's law. So I'll suggest the students to write the definition from the textbook, not from your reference books. So here is the Ohm's law. Remember, if the temperature is not kept constant, then the property of the conductor is going to change. So this is the statement: the potential difference V across the ends of a given metallic wire in an electric circuit is directly proportional to the current flowing through it, provided temperature is kept constant. And we are supposed to write the expression for this also. So current will be represented by I, capital I. So we can write the potential difference is directly proportional to current, and if I remove the proportionality, I need to write the constant R. Remember, this constant R is the resistance, and that is dependent upon the temperature. So resistance is what going to change, and if the temperature changes, this V will not be proportional to I. So you have to keep that in mind. Your statement should contain this point, that the temperature is to be kept constant. That's very, very important, else the Ohm's law is not valid. I suppose you have understood. Still, if you are having any doubts, please let me know. I'll try to clear them. So let's move on to the next question. The next question is a 19th question, and that is a paragraph question. So let's jump. Question number 19. Let me read the instructions. Question numbers from 19.1 to 19.5 are based on the table related to the values of absolute refractive index of different material mediums. Study the table and answer any 4 questions from 19.1 to 19.5 that follow. So there is a table for you. This is table 10.3. Just to see the table, or if you have textbook with you, just keep the textbook in front of you while we are answering the question. There is no need to memorize any value of refractive index except for vacuum or air. All other things will be given in the question, so no need to memorize. So let's see the first question, 19.1. In the exam, please mention your questions neatly in the margin, so that it would be very easy for the examiner to correct and give you marks. So the question is, name the medium with the highest optical density. So as we have already discussed, more the refractive index, more is the optical density, slower will be the velocity of light in that medium. So the one who is having the maximum refractive index, and that is diamond. How much is its refractive index? You can see in the table, it is 2.42. So this is the one which has a highest optical density. 19.2. Find the medium with the least optical density. So if you see the table, you will have air being the least, the one with least optical density, but there is one more medium. That medium is vacuum, and its refractive index is 1. If you compare vacuum and air, their refractive indices are almost same, but even though air is optically denser than the vacuum, so the one which is the rarest optical medium is vacuum, which consists nothing, and the speed of the light in that medium is maximum. And how much is its refractive index? That is 1. Next, third question, 19.3. Out of kerosene, water and alcohol, where will light travel fastest? Now see the table which is on this side. Now compare which has the least refractive index out of the three: water, kerosene and alcohol, and it is water, which has a refractive index of 1.33. The less refractive index, if refractive index of water is least out of the three, and hence the speed of light is maximum. No need to write this, just this answer is enough. This is just for 1 mark. Okay, we will have 2 more questions in this for this paragraph. 19.4. Calculate the speed of light in benzene. Calculate the speed of light in benzene. So see the table. So according to the table, refractive index of benzene is benzene C6H6 1.50. This is from I have taken from the table. Now according to the definition, what is refractive index? It is the ratio speed of light in vacuum to the speed of light in the medium. What is the medium? Benzene. So we will write it as a velocity in benzene, and the question wants V benzene, velocity of light in benzene. So velocity of light in benzene is C by refractive index in benzene. So what is C? C is speed of light in vacuum, 3 into 10 power 8, and refractive index of benzene 1.50. So if you calculate 1.5 ones are 1.5 twos are 2 into 10 power 8 meter per second. Now this is the velocity of velocity of light in benzene. It is 2 into 10 power 8. I hope you are getting this. Okay. And for the last question, you have to write, remember, out of 5 questions you have to write any 4. So check which one is best for you. Now the last question, 19.5. How much faster does the light travel in crown glass as compared to diamond? So from the table you have to take the refractive index of crown glass. How much is refractive index of crown glass? See the table. Refractive index of crown glass is 1.52 and refractive index of diamond is 2.42. Through which of these two media the light is going to travel faster? So it is the crown glass. So we will find what refractive index of diamond with respect to crown glass. So this is equal to refractive index of diamond by refractive index of crown glass. So these are the absolute refractive indices. And how much is that? 2.42 divided by 1.52, and if you calculate the approximate value here, it is around 6. So we have option 1.59 times faster. I just made a guess, plus you do not do guesses in the examination, you just calculate that. So that was your paragraph question, which was related to the table of absolute refractive indices. Now let's do the last and the final question, that is also a paragraph. So let's begin. Read the following and answer any 4 questions from 21 to 24. So this question is 20. So there is a diagram there, and before showing you the diagram I would like to read the passage given there. The passage is, the exact cause of Earth's magnetism is not known. However, one of the postulates is that the Earth's core is extremely hot and molten. Circulating ions of iron and nickel might be forming current loops and producing Earth's magnetic field. The strength of this field at the surface is around 10 power minus 5 Tesla. Now let me show you the diagram on this side. So here is the diagram. So the first question, 21. What will happen to a freely suspended bar magnet? So if I place here, the earth itself has some magnetism. So it is showing magnetic properties. That means it will have a north pole and it is also having a south pole. And if you see the figure where we are indicating geographical north, there the magnetic south pole exists. And second thing, where we are indicating the geographical south pole, there the magnetic north pole exists. So you can consider earth having a bar magnet inside it, just for imagination purpose. And there is a small change in the angle, and both geographical north south pole and magnetic north south pole are not perfectly aligned with each other. There is some angle between them. So if I have a bar magnet in my hand and if I suspend it, so obviously it will show some deviation because of the magnetic property of the earth. And what would be the effect? The effect will be, it will align in geographical north south direction. The bar magnet will align in geographical, not perfectly, almost north south direction. So you will read about this more in class 12th. Next question. So I will make some space for that. 22. Which is true of the Earth's magnetic field? 1. The field lines of Earth's magnet always travel from geographical north to that of south. 2. Field lines of Earth's magnet always travel from magnetic north to the magnetic south. 3. The magnetic north of the Earth's magnet is in the North Pole. 4. The magnetic north of the Earth magnet is in South Pole. 5. Field lines of the Earth's magnet originate in the geographical South Pole and travel in geographic North Pole to form closed loops. Now I will show you the diagram again. So which of the following options are correct? Closely look at the statements given there. Now here are the options. A, 1, 3 and 5 are correct. B, 2, 4 and 5 are correct. C, 2, 1 and 3 are correct. D, 2, 3 and 5 are correct. So these are the options. Now look at these statements, observe them carefully, and also see the diagram. Now which of the following statements are correct? Statement 1. Field lines of the Earth's magnet always travel from geographic north to that of south. Geographic north to geographic south? No. The magnetic poles are aligned. South pole at the geographic north and the north pole at geographic south. So field lines will travel from north pole of the magnet to south pole of the magnet. Or if I talk in geographic terms, it is from geographic south pole to geographic north pole. So statement 1 is wrong and statement 2, 4 and 5 are correct. See there, it explains those things, right? 2, 4 and 5 are correct. Third one, the magnetic north of Earth's magnet is in North Pole. No, there we have a South Pole. So the choices or the statements 2, 4 and 5 are correct. So we'll go with the option B. Now let's see the next question, and there is a diagram for you. Question 23. So see the diagram. The diagram shows a compass at rest. Pick the correct statement. Statement A. A compass can be used to find the exact geographic north as the magnetic north and geographical north are the same. Is it true? No. So the statement A is not correct. Let's see the statement B. A compass cannot be used to find the exact geographical north as the magnetic north and geographic north has an angle between them. Yes, this is true. We cannot find the exact north, but we can find almost north. So statement B is correct. Now let's see the 24. So see the diagram carefully. The small angle formed between the magnetic axis and geographic axis is defined as magnetic declination. So the angle between magnetic axis, that is the line joining magnetic north and magnetic south poles, and at geographic axis, what is geographic axis? The line joining geographic north and geographic south pole will have some angle between them because they are not perfectly aligned along with each other, and that angle we are calling it as declination or declination. We are calling it as declination. In the figure, which alphabet represents the declination, A or B? So see the diagram carefully. So that angle is B. 25. Is the magnetic field scalar or vector quantity? So magnetic field is a vector quantity. It has both magnitude and direction. So this is the end of this video. So as you have seen, in this video we have discussed all the questions. We have discussed 18 questions, 18 really good questions, and I hope that it has improved your concept and will help you in the examination. So prepare well, practice previous year's papers, read the textbook properly, and if you have any doubts, please ask at Facebook, Telegram or in the YouTube comment section. And please subscribe to the channel, like the video and share with your friends and family members. We'll meet soon.